Hi students, today I am going to discuss dynamics of circular motion. Okay, what is the topic? Dynamics of circular motion. So we already discussed circular motion, horizontal circular motion. Okay, now in today's class, I am going to discuss this dynamics of circular motion. That is, which is the force necessary for a body to move in a circular path. Okay. So, as we discussed, when a body moves in a circular path with uniform speed, it has centripetal acceleration towards the center. Okay. And when it is moving in a circular path with variable speed, it has two types of accelerations, centripetal acceleration and tangential acceleration. The corresponding forces are centripetal force and tangential force. So when a body moves in a circular path with uniform speed, it requires a centripetal force. That centripetal force is acting towards the center. Okay, it acts towards the center. It is a necessary force for a body to revolve in a circular path. When a body has a tendency to move in a circular path, it must need centripetal force. In practical applications, this centripetal force is provided by some external agencies like gravitational force and tension in the string and Coulomb's force of attraction between the nucleus and electron will provide or normal reaction or frictional force. These are the real forces provides necessary centripetal force to the body to revolve in a circular path. Okay. So for a body to move in a circular path, it requires centripetal force, that is center seeking force, and it acts towards the center. It requires a centripetal force. It is provided in applications, the real forces like gravitational force, frictional force, normal reaction, Coulomb's electrostatic force, tension in the string, Okay. So it is provided in applications, real applications, the real forces like gravitational force, frictional force, normal reaction, Coulomb's electrostatic force, tension in the string provides this is necessary centripetal force. So provides, it is provided in applications the real forces. Okay, now the centripetal force is given by we have centripetal acceleration. So we derived centripetal acceleration. What is the centripetal acceleration? N is equal to v square by r omega square, or we have v bar cross omega bar, isn't it? V bar cross omega bar. V is equal to, okay, so these are the centripetal acceleration. So centripetal force, tangential acceleration we have in non-uniform circular motion, at is equal to dv by dt, or we have r times alpha, or we have r bar cross alpha bar, alpha cross r bar. Okay, we have this relation. Here it is omega bar cross r bar. So alpha cross r bar. Okay, so this is a tangential acceleration. It is for non-uniform circular motion. Non-uniform circular motion, it has circular motion. That is, body moves with a variable speed. Here body moves with a uniform speed. Then it has centripetal acceleration only. The corresponding forces are called centripetal force. Centripetal force, we have, you multiply this acceleration with from Newton's second law. We have F is equal to ma from second law. So Newton's second law we have. So centripetal force is given by m. What is a? V square by r. So mv square by r, that is equal to mr omega square, or we have mv omega. Okay, since v and omega are perpendicular to each other. So these are the formulas for centripetal force, where m is mass of the body, r is radius of the circle, circular path, omega is angular velocity or speed. Okay, so this centripetal force, it acts towards the center. When a body is moving in a circular path, so the centripetal force acts towards the center. Okay, now when a body moves in a circular path, let us see. When a body moves in a circular path, the centripetal force is acts towards the center. So it is center seeking force. So velocity will be tangential to this. So this force is necessary for the body. So acceleration will be also in this direction. So the angle between velocity and acceleration is 90 degrees. So this force is necessary for a body to revolve in a circular path. In the absence of this force, the body may move tangentially. It will fly. In the absence of this force, centripetal force, the body will fly tangentially. Okay? So when a body moves in a circular path, there will be another force, that is a fictitious force acts on the body. That is centrifugal force. Centrifugal force which is acts away from the center. Okay? That centrifugal force, this is centrifugal force. The centrifugal force has the magnitude which acts away from the center. The centripetal force is acts towards the center. Okay? So this centripetal force is provided by the real forces like a tension in the string and gravitational forces, normal reaction, frictional forces, and Coulomb's electrostatic force will provide the necessary centripetal force. So this centrifugal force is acting on the body which is moving in an accelerating frame. So it is a fictitious force. It is a fictitious force. Centrifugal force is a fictitious force, or we can call it as pseudo force. Pseudo force. Okay? It is a pseudo force. So acts on the body. Okay? Now I will try to explain it here with the help of some examples. The magnitude of centrifugal force is equal to magnitude of centripetal force. Okay? The magnitude of centripetal force is equal to magnitude of centrifugal force. Let us see. I will try to explain with some examples. Okay? So the next one is applications. Applications of circular motion. Okay, the first one. A body is placed on a rotating disc. Okay, at a distance r from its center. Let it be a rotating disc. This is rotating disc or table. A body is placed at a distance r from center. So this is axis of rotation. So let omega be the angular speed of this body, rotating disc. It is rotating like this. So a body is placed on the rotating disc at a distance r from the center. Now the body is rotating along with the disc up to particular speed only. When it is rotating along with the disc, there will be pseudo force acting on that. That is centrifugal force. That will tries to throw this body away. That is balanced by this centripetal force. That is this frictional force here between this block and the surface will provide some necessary centripetal force to this object. Okay? So here the concept is this block is rotating along with the disc. It requires a centripetal force that is provided by frictional force between this block and the disc and this block, this body. If there is no friction, it will slips simply. So it can't rotate along with the disc. So here friction is responsible for the rotation. Okay? So a body is placed on a rotating disc. A body is placed on a rotating disc rotating disc, rotating disc at a distance of, on a rotating disc, a body is placed on a rotating disc, then frictional force between the body and the surface, body and the surface, horizontal surface, provides necessary centripetal force, necessary centripetal force, So that is the concept involved here. So the frictional force, the centripetal force is provided by frictional force. But friction has limiting value. Frictional force has limiting value. But this rotation speed may goes on increasing. So the centripetal force, that is mr omega square or mv square by r, it should be less than or equal to this limiting frictional force, Fl. So what is Fl? mv square by r should be less than or equal to, what is frictional force? Mu n. What is n here? Frictional force is mu n. What is n here? For normal surface, it is mg, where mu s is coefficient of static friction. Okay? So this is the condition should satisfy. Okay? For the body to move along with the disc. If this condition is not satisfied, then what happens? The body will be thrown away. If this speed will be, if it is more than this value, then its body will be thrown away. Okay? So this is the first application. And second one. Okay? Second one. Second one is, a body is tied to a string. A body is tied to a string of length L. A body is tied to a string of length L and rotating and whirled in a horizontal circle. And whirled in a horizontal circle. Okay? So the tension in the string, see, here let it be, this is a body, this is a string. Okay? This string is having the length L, so which is equal to radius of the circle. So m is mass of the stone, let it be. Body, let it be a stone. This is tied to a string and it is built in a horizontal circle like this. Okay? So the tension in the string will provide the necessary centripetal force to the body. So that is the concept involved here. Okay? If this tension in the string it has its own breaking strength. So if you rotate more than that its strength, so it will be string will be breaks and the stone will fly tangentially. So this tension in the string will provide the necessary centripetal force. Okay? in a horizontal circle. Then tension in the string, what is the concept involved here? Tension in the string will provide the necessary centripetal force. Okay, so what is the centripetal force? Tension in the string, let it be T, is equal to centripetal force is mr omega square or mv square by r. Okay, here v is linear speed of the stone, omega is angular speed of the stone. Linear speed is meter per second, angular speed is radian per second. In the given problem, we can choose any one. Okay, or both are related according to the equation v is equal to r omega. We can convert from one to other by using this relation v is equal to r omega. So the tension in the string will provide the necessary centripetal force. If T is the breaking strength of the string, breaking strength of the string in newtons, okay, that is a force in newtons. If T is the breaking strength of the string in newtons, then mr omega square should be less than or equal to T. Otherwise, if mr omega square greater than T, string will breaks. So what is the maximum time period of this string without breaking? So what is the maximum frequency? I want maximum frequency of rotation without breaking the string. I want. So that maximum frequency is it should be mr omega square should be less than T. So that is omega square should be less than or equal to T by mr. So that is T. So angular frequency is, I want omega, it should be less than or equal to T by mr. This is the maximum frequency of rotation. So its maximum value is square root of T by mr, where T is breaking strength of the string. Okay, wait, so you take this, so this is maximum angular speed. Suppose you want a time period, so omega can be replaced with 2 pi. So omega can be written as 2 pi by T, or we can write it as 2 pi f. Should be equal to it should be less than or equal to T by mr. So if you want the maximum frequency or minimum time period, maximum frequency of rotation is 1 by 2 pi into square root of T by mr without breaking the string. or minimum time period is, maximum frequency makes minimum time is 2 pi into square root of mr by t, because frequency and time period are related, inversely related to each other. Since we have t is equal to 1 by m. Okay, you take this. Next application. Okay, the next application is conical pendulum. So this is the third one, conical pendulum. Okay, so conical pendulum. What is a conical pendulum? A body is tied to a string and built in a horizontal circle. One end is fixed to the roof, other end is rotated in a horizontal circle like this. So if it rotates like this, it sweeps like a cone, making an angle theta with vertical. So the string makes an angle theta with vertical. Such a pendulums we can call it as conical pendulum. So what is a conical pendulum? It sweeps like a cone. So this pendulum, this letter, a pendulum is rotated in a horizontal circle, with uniform speed, with angular velocity, omega. Then string sweeps like a cone, making an angle theta with vertical. Such a pendulums we can call it as conical pendulum. Okay, so if L is the length of the pendulum, okay, let it be L. So I assumed that let L be the length of the pendulum. I assumed here length of the pendulum. Okay, let M be the mass of the bar. Let T be the tension in the string. Okay, so this is the bar. So what are the forces acting on the bar? If M is mass of the bar, so the tension in the string will act towards the fixed point O. O is the point of suspension. Okay, point of suspension. Now it rotates in a circular path of radius small r. Okay, so what are the forces acting on the bar? Its weight mg vertically downwards, the tension in the string towards the fixed point along the string, and the resultant of these two will provide a centripetal force. No, not resultant force. The component of this tension in the string will provide necessary centripetal force to this bar. So you resolve this tension in the string into components. So this is, if angle is theta, then this opposite angle is also theta. If this is the t, then its component here it is t cos theta. This is t, its component is t cos theta, and t sin theta will be in this direction. This component of tension t sin theta will provide the necessary centripetal force to this bar. That's why it rotates in a circular path. So this mg balances with the t cos theta. So here which component of force will provide the necessary centripetal force here? T sin theta provides necessary centripetal force, that is mv square by r or mr omega square. Okay, we can write either one in these problems. Okay, t sin theta will provide this, and t cos theta balances with the mg. Okay, these two are the equations. Equation 1, equation 2. Okay, if you divide this, what you will get? So from equations 1 and 2, you divide these two. So you will get a sin theta by cos theta, tan theta. T will get cancelled. mr omega square by mg. m get cancelled. So but r is equal to, in this triangle, r is equal to, this is r, circular path radius, this is L, length of the string, this is theta. Then how these three are related? By applying sin theta is equal to, okay, sin theta. Now say, as we are dividing these two, we will get tan theta is equal to v square by rg. So here r is this radius of the circular path, L is length of the string, and theta is angle swept by this string with vertical. So how this L, R, theta are related? From diagram, sin theta is equal to, so we have sin theta is equal to R by L. So we have R is equal to L sin theta from this triangle. Okay, so instead of R, I am writing L sin theta. So here I am writing tan theta can be written as sin theta by cos theta, and v square by r. Instead of r, can I write L by sin theta, L by this is L and this is r. R is equal to L sin theta. So v square by rg. So here sin theta, tan theta is equal to v square by rg, and instead of r we can write L sin theta into g. So here tan theta is equal to v square by rg. So I want v is equal to root rg tan theta. So that is linear speed of this bob which is rotating. Suppose you want angular velocity. You have to equate this. Angular velocity mv square by r can also be written as mr omega square. Okay, so if you write mr omega square, what you will get? Get cancelled, we will get r omega square by g, or both are equal. If you write mv square by r, you will get this. If you write mr omega square, you will get r omega square by g. Okay, so you get root rg tan theta, omega is equal to, you will get g tan theta by r. Okay, that is omega under root. This is angular speed. Okay, so instead of r, we can write L sin theta. Okay, instead of r, we can write L sin theta. So this is tan theta, g tan theta by, instead of r, we can write L sin theta. Okay, here sin theta get cancelled. You will get a denominator cos theta. So that is, you will get g by L cos theta. You will get, since tan theta is equal to sin theta by cos theta, sin theta will get cancelled, denominator cos theta will remains. So this is the angular speed of this bob which is rotating. Suppose you want a time period. Time period is 2 pi by omega. So that is 2 pi by, what is omega? Root, we can write it as L cos theta by g. Okay, where L is length of the string. So this is expression for time period. Okay, so this L cos theta, here L cos theta, this is L. If you take this height as h from point of suspension to the bob, height of the bob. If you take this one as h, then if this is the length of the string L, this is theta, then this h becomes L cos theta. So from this triangle, if you have cos theta is equal to h by L. So h is equal to L cos theta. So you have these two expressions from the above triangle. So here instead of L cos theta, I am writing h. So the time period t is equal to, we can also write it as 2 pi into square root of h by g. Okay, what is h? Height of the bob, where h is height of the bob. Height of the bob from point of suspension. This is point of suspension. Okay. So here we can also write it as this is expression for time period. Okay, if you want expression for time period, you have to write this one or this one in terms of L. What is L here? Where L is length of the string. Length of the string or length of the pendulum. Length of the pendulum. Okay. Now instead of t, we can write it as 2 pi by omega. 2 pi by t becomes omega. Bring this t this side, you will get the square root of g by h. Okay, so what is 2 pi by omega? Angular speed is equal to square root of g by h. Okay, so from this we have the expression omega square, or h is inversely proportional to omega square. If squaring on both sides, what is g? G is acceleration due to gravity, which is constant. What does it mean here? H is inversely proportional to omega square. What does it mean? As this speed of this pendulum, goes on, it is rotating with more and more speed. What happens? This height will decreases. So the bob will rise like this. As you increase the speed, the bob will rise like this. Okay, so the bobs, ends of the bobs, these are the two. If you assume as these two are the wings of my hand, so if you increase the speed of rotation, these two bobs, height will decrease. That means the bob will rise like this, and ultimately this height will be decreases. Okay, so this is the context of conical pendulum. This is one of the applications. You may get problems based on this. Take this. Okay, next application. So I think this is the fifth application. Depth well or rotor. Depth well or rotor. You might have seen in circus a person driving a motorcycle in a vertical globe. A wooden well will be there. A person drives the motorcycle on the vertical walls of a well, wooden well. So if he falls, he may die. So that well we can call it as depth well. Okay. So if he slips, he will fall down. And so the person driving the motorcycle on the vertical walls of a wooden well, and how it is possible, now we are going to see. And we might see in rotor, suppose there is a well, a rotating cylinder, a person hangs against a vertical walls of the vertical walls of the rotor. If the rotor rotates with a certain angular speed, a person hangs in air against the vertical wall. How it is possible? These two are based on the same principle. Let us see. Okay. So, a person drives a motor vehicle in a drives a motor vehicle on a vertical surface of a wooden well. Okay. A person drives a motor vehicle on a vertical surface of a wooden well, and a person can hang. A person hangs in against a vertical wall. Against a vertical wall in a rotor. Rotor is a cylindrical vessel. What is a rotor? Cylindrical vessel which rotates with a certain angular speed about its own axis. Let us see how it is possible. Let it be a well, cylindrical well. Okay, let us assume let it be a wooden well. Okay, So a person drives the motorcycle on the vertical surface. This is a cylindrical surface. How he drives the motorcycle on the vertical walls of a wooden well? He drives against the vertical wall. So here he drives like this against a vertical wall. Okay, he drives like this. So when he is driving on the vertical surface, he has to exert certain force on this vertical surface. That this surface is fixed one, and it in turn exert normal reaction. That force exerted by this vertical wall on the person will be N. Person is rotating. While rotating, he exerts certain force on the vertical wall. In turn, the vertical wall exerts same amount of force on the person. Let it be N. That is called normal reaction exerted by this vertical wall. It is this normal reaction will provide centripetal force to the vehicle. So the person wants to drive in a circular path. So he needs a centripetal force that is provided by this normal reaction. And what are the other forces acting on the person? Weight of the person acts vertically downwards. So gravitational force acts vertically downwards. And one more force is there, that is frictional force. That frictional force F acts vertically upwards. As I said, vertical friction is a self-adjusting force. Its direction will be adjusted. Itself changes. Okay, so here the frictional force is act vertically upwards on the vertical surface. So what are the forces acting on the person? The forces acting on the person, acting on the vehicle or person together, we can call it as F frictional force, and this frictional force is given by mu n, where mu is coefficient of friction and forces acting on the person. This is the first force. Second one is normal reaction. This normal reaction will provide a centripetal force to the person. So centripetal force is mr omega square, where r is radius of this cylindrical vessel. R is radius of this cylindrical well. So R is radius, m is mass of the person, omega is angular speed. So these are the second force, and the third one is weight mg, that is weight of the person. Weight of the person mg. Weight of the person mg. So here, so I will write what is R here? Radius of the cylindrical vessel, radius of the vessel or well, radius of the well, and omega is angular speed of the person. What is m? Mass of the person including vehicle. Mass of the person including vehicle. And m r omega g. Everything I explained here. Mu is coefficient of friction. Between the surface, vertical surface and the vehicle. Okay. So under equilibrium, so to balance this, so the equilibrium, it requires a necessary centripetal force. Instead of n, these two will balance. Okay. So these two forces should balance and it provides necessary centripetal force. Here I said normal reaction will provide necessary centripetal force. So what is the concept involved here? Here normal reaction N provides necessary centripetal force. So that is the concept involved. Okay, this is the concept involved here. So N balances with mr omega square. Now under equilibrium, so for equilibrium this frictional force F should be greater than or equal to mg. Okay, so it is a self-adjusting force. So F is mu n, so mu n greater than or equal to mg. Mu n is mu into what is n? mr omega square should be greater than or equal to mg. M get cancelled, so it is independent of mass. So the speed of the vehicle is, I will write here. So speed of the vehicle omega is, I will write here. So omega is equal to, omega square should be greater than or equal to, for balancing G by mu r under root. So this is the necessary condition for the person to be in stable equilibrium, okay, without falling. So the speed, it should maintain certain minimum speed. So what is the minimum speed of this one? Minimum speed is, it is equal to square root of G by mu r. So this is the minimum speed of the vehicle. If it maintains less than this, what happens? He will fall down. Okay, he will falls down. So the person should drive a motorcycle in a vertical well, he should maintain certain minimum speed. That depends upon mu, friction between this vertical surface and the vehicle. If there is no friction, he will slips, fall down. R is radius of this vehicle, radius of this wooden well, cylindrical well. If radius is more, if radius will be less, he has to maintain more speed. Radius will be more, he has to maintain less speed. Okay, so this is the speed depends upon radius and mu. On the other hand, a person hangs against a vertical wall. If the same principle we can apply, if this cylindrical vessel is rotates, suppose a person is standing here, the same principle extends. The cylinder is rotating, reverse. Person is at rest, cylinder is rotating. Here, in the previous case, cylinder is at rest, person is rotating. Clear? Observe these two. So here cylinder is rotating, that is called rotor. Object which rotates, rotor, which rotates. So a person is at rest, he can hangs against this vertical surface because centrifugal force acting on it, that is fictitious force acting on it. Because of that fictitious force he experiences, since he is in non-inertial frame of reference, he experiences centrifugal force. So he thrown away from center, like centrifuge. He thrown away from center. That means he exerts certain force on these walls. This wall in turn against certain force M. That will provide the necessary centripetal force. Okay. Here the weight of the person balances with the frictional force. Clear? The same two applications, the concept is same. Okay, take this. Next application.